All right, so I think I might as well go ahead and get started. I genuinely have like 45 minutes worth of content unless I speak super, super fast. So I'll go ahead and get things rolling. So my name's Tyler Croy. That should be fairly obvious because you can read it up there. And I'm assuming because you're all here that you know what Jenkins is, so let's pretend this slide isn't in this presentation. The one thing that I do like to call out about Jenkins when I introduce it is that the Jenkins project is a fully open source and independent project. We're affiliated with an organization called Software in the Public Interest, which is the same legal umbrella that the Debian project is under, that the Postgres project and a couple others are under. So the Jenkins project is a pretty standalone thing that a lot of people are contributing to, and we're thankful for the support that the SPI gives us. We also have a lot of sponsors, and I know there's conference sponsors, blah, 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 but these are some of the organizations that help the Jenkins project be successful in general. So Cloudbees is my employer now. They weren't my employer for a long, long time. They actually spend a lot of developer time making Jenkins the open source project better, but also sponsoring some of our current infrastructure costs, which is cool. We also have a lot of support from the Oregon State University Open Source Lab, which is an organization, I think, unparalleled in the open source ecosystem in that there's an academic program behind the Oregon State University Lab that helps students and academics participate in open source projects. They host a lot of the Apache Software Foundation's infrastructure. They host some of our infrastructure, and we're really grateful for their work. You heard about Microsoft in the keynote earlier. They've stepped up and partnered with us to run our project infrastructure for the next couple years on Azure, which I'm really excited about. And then we also have support from PagerDuty, Datadog, and Atlassian. So Atlassian you might see if you have ever been to the Jenkins Confluence, our wiki, or our Jira issue tracker. We have an open source license from Atlassian for those, which we're thankful for. But PagerDuty and Datadog you don't actually see, because I'm assuming that most of you, unless we've accepted people into the project that I don't know about, are not contributing to the Jenkins project infrastructure. So Datadog and PagerDuty are actually some of the tools that we use to run the project infrastructure itself. So that's cool. I work at Cloudbees now as a Jenkins evangelist, which basically means I do pretty much the same thing I was doing before I joined the company, where I work on the project a lot and I go talk about the project a lot. I'm a board member with our governance board right now, and pretty much the majority of my contributions to the project have been in the project's infrastructure. So I don't work on plugins, I don't work on core. I help make sure that the bits on Jenkins.io get delivered to you and things like that. And when I talk about infrastructure, I really mean a couple things. Generally speaking, I'm referring to some resources that you might be familiar with, like load balancers, virtual machines. Those I consider infrastructure. The configuration management code that we use to manage those resources, I consider part of infrastructure. Our packaging tooling, whether Debian or Docker-based packaging kind of stuff, I consider infrastructure. Our deployment tooling, the scripts and the Jenkins files that get stuff from points A to point B, that's part of infrastructure. And then our monitoring and alerting, that's arguably one of the more important parts of infrastructure. But when I talk about continuous delivery of infrastructure, I'm referring to this very large grouping of different things that most operations personnel have to worry about. And in the Jenkins project, we actually have a deceptively large amount of services running around that if you're just a Jenkins user, you might not be aware of. If you're a plugin developer, you might not be aware of some of the others. But we run Jenkins on Jenkins. ci.jenkins.io is publicly available. Most of our CI and CD stuff is visible on ci.jenkins.io. We run a few developer tools like our Jira and Confluence. We also have some miscellaneous bots and other things running around. Our release infrastructure is actually probably the most unique and interesting for people coming from different operations organizations or from different open source projects. The Jenkins project, the last time I counted, which was earlier this year, ships about 55 terabytes of data a month. So that's plugins, update centers, Jenkins core, to hundreds of thousands of Jenkins installations around the world. And so the release infrastructure that we have behind that to make sure that we can deliver 55 terabytes of data is non-trivial, to put it bluntly. And it wasn't always this mature. My sort of entry into the project was in 2008. I created the then, we were called a different name then. I created an IRC channel basically because I wanted help from Kosuke. That's how I got into the project, is I goaded Kosuke to join IRC so I could pester him with questions. And at that time, the way that the infrastructure, I'll use bunny ears, infrastructure worked was there were machines at Sun that were squirreled away somewhere that had various things running on them, like Jira, like Confluence, and they were all manually set up. And if you needed access to those to fix something, if you were on good terms with Kosuke, he would just give you access and you could go change things manually. So there was like no audit trail, no nothing. It was all magic manual snowflakes. But in 2011, I had learned about Puppet where I work. And like most people, when I learn a new thing, I want to hit everything with that new Puppet hammer. So we started using Puppet inside of the Jenkins project. And what we started to do then is use virtualization at the Oregon State University open source lab. We started to introduce masterless Puppet and some semblance of infrastructure as code. At the time, infrastructure as code was just starting to become a popular thing, which is how I had learned about it. And this version of our infrastructure as code was so bad that in 2014, we rewrote all of it and fixed a lot of the problems that we had with it. But our development tools at the time were very basic. I remember complaining to a lot of the members of the Puppet community, like, you keep saying this as code, but I can't write tests for this stuff. The best I can do is lint. Like, how can I call this code if I can't develop it like I would any other piece of code? By 2014, which is the current incantation of infrastructure that we're on, the Puppet community had grown quite a bit. The infrastructure as code or infrastructure management, DevOps, whatever you want to call it, ecosystem has matured dramatically in the last 2 years. So we revisited the way we were doing a number of things, and we introduced centralized Puppet. So we have a Puppet master now running, and we have Puppet agents on our nodes. We also introduced Docker, which I fought against. I said, Docker is hyped bullshit. I won't see any of it. And Kosuke persuaded me that it was a good idea, and it's turned out to be a good idea, and I'll explain why. But our development toolchain also matured quite a bit. If you're using Puppet right now and you're not using a tool like R10K, I can't recommend it strongly enough for managing the modules and the different environments that your Puppet master might be responsible for. But along with that, server spec came of age, and RSpec Puppet came of age. So prior to 2014, we didn't really have good test tooling around our infrastructure as code. Now, this is my personal opinion, I don't think there's any excuse not to be writing tests for your infrastructure as code to verify what you say you're doing. But there's a lot of stuff that goes into infrastructure. This is like 10, 20 different kinds of things. There's packaging, there's monitoring, there's the actual assets that you might have in a data center or in AWS. This is really hard. If you aren't familiar with operations people or don't know any operations people, they're usually a little bit negative, a little bit grumpy. They're not the most friendly people when you first get to know them. And the reason is that there's so much shit that has to be done to make infrastructure work that most operations people always feel like they're under attack or they're always behind. They're running from behind and trying to catch up. And that's people that are paid to do this. People that volunteer to do this are even grumpier and more surly. And people like myself who volunteer to take this kind of workload on, I'll get paged for the Jenkins project because I want to, which is a weird thing to say. But no one's paying me to really do it. And in addition, a long-term open source project like Jenkins has been around long enough that we have sort of assets sprinkled around the world, really. Right now, and this is because we haven't gone through with this Azure migration, we have assets in 4 different data centers. And what that means is I've got we're now down to 1 physical machine in a data center. I've got some rack space assets, I've got some AWS assets, and I've got some virtual machines that were provisioned with a tool called Ganeti at the open source lab. And none of those are sort of consolidated in how I work with them. So I've got to work with 4 different types of data centers. And our PagerDuty rotation is also very small because no one wants to volunteer to be woken up at 2 a.m. because a disk is full or something like that. So it's very difficult to actually work on open source infrastructure, which is, this is kind of the weirdest segue. Open source infrastructure is really, really hard, therefore continuous delivery. So come with me on this one. Without continuous delivery, or without automating, I would be so underwater, I wouldn't want to be with the project anymore, to put it bluntly. Because without that automation, we simply couldn't survive on this shoestring budget with a few people around the world that are volunteering for infrastructure. So continuous delivery has actually been the linchpin for our survival as a small team. And when I'm talking about continuous delivery, really it's the automation to make sure that every commit or every change we can build, test, verify, and deploy out to production in some transparent, obvious way to where if Kosuke makes a change or if another member of the infrastructure team makes a change that I'm not aware of and it goes out, I can then backtrack to see what happened, why, and where. And I've been doing this a while now, and the most common complaint that I'll get around continuous delivery, professionally and in the Jenkins project, is that we can't do it because it's really hard for us to deploy, which is one of the biggest cop-outs I've ever heard. If it's so hard to deploy, why don't you just stop deploying? Like, you're there in your organization. You're there to build and ship code, right? Whether it's infrastructure code or applications. So if it hurts for you to deploy, then deploy more. Get better at it. Like, don't sit around and just suffer. Like, automate things that hurt. And that's what we've started to do in the Jenkins project. Now, most of you, I would hope, are using Jenkins as part of a traditional sort of CI/CD delivery process. And you might have the build part going on in Jenkins. You might have the test part going on in Jenkins. But there's these different steps that might be sitting outside of Jenkins. And one of the things that we've started to do is move more and more stuff, more and more components of that pipeline into Jenkins. And we do that with the Jenkins pipeline. And the reason that I wanted to do this presentation console mode only is because almost every Jenkins presentation I had given prior to this has included screenshots of Jenkins, and we've all seen enough of that. But with console-based, I can't show you any screenshots. So everything either has to be code or text, which is how I want to work with things as an operator. So Jenkins becomes part of the CD hub with the pipeline plugin. We'll skip through some of this stuff. And the big point of the pipeline plugin and why it's valuable to me as an operator is my pipeline can be defined as code and checked into the repository that the code that is being deployed lives inside of. So if I need to know how a certain Docker container is deployed or what goes into the delivery of that, I go to that Jenkins project repository and I look at the Jenkins file, and then I know what's supposed to be going on. And that also means that we can have contributions go for those Jenkins files. So someone can come along and say, well, we can do more testing here, or we should be building this Docker container differently, and submit a pull request to update the way we build and ship code, which for an open source project is incredibly valuable. But if you're working in an organization that's not working on an open source project, having that ability to define a Jenkins file to where new members of the team, whether engineering or QA or somewhere else in the organization, can participate in the definition of delivery can be immensely valuable. Most developers, application developers that is, might not consider what the application security team wants, for example. They might not consider what the operation team wants. But by defining things in a Jenkins file, I now have a point in sort of space-time that we can all collaborate around and decide what needs to happen for your responsibilities in the software delivery process versus mine, and so on and so forth. So I wanted to show off a basic Jenkins file, which I am assuming most of you have seen some form of this. If you pull this Docker container, and don't do it on conference Wi-Fi, all of this stuff is actually bundled into that Docker container, the examples as well. So let's look at a basic Jenkins file. Now, some of this stuff I showed in a demo that I gave at the Open Source Hub earlier. But in this sort of contrived example, I'm building and testing a Java application. So I'm actually using a plugin called the Cloudbees Docker Pipeline plugin, which is open source in the Update Center right now, to run some steps inside of a running container. And so when I call this Docker image Java 8 JDK.inside. On a Jenkins agent in my cluster, a container will be provisioned, a Java container with the tag 8 JDK, and then I can run parts of my build steps inside of that container. And what this gives me as an operator is I no longer have to be terribly worried about what's going to be installed on those Jenkins agents ahead of time. I can simply allow the Jenkins files to describe what containers I need or what system dependencies I need to build and test my software. And so we might need to run some Gradle bits, right, and archive some of our work for later. And probably the most useful step in here if you're building out a pipeline is the Stache Step, which means hold on to these files that I've created inside of this container. Hold on to those until later in the pipeline. So once I get down to test, I can go through sort of the same kind of thing. I need the JRE to run my tests. I can provision a JRE Docker container. I might need to grab my acceptance test harness from somewhere else. In the Jenkins project, for example, we have a separate repository with a lot of Selenium tests that lives outside of Jenkins core because we test plugins and things like that along with it. And we'll grab that and then unstash the built application, and then we can start running our tests on it. And this is a very sort of basic, contrived Jenkins pipeline. But the benefits for me as an operator, or me as a contributor, are tremendous compared to previous freestyle jobs in Jenkins. Because if something goes wrong, or if something's off, I can use git blame to figure out what changed. I can look through the commit history. I can submit pull requests, and I can work on this as if it was just another piece of code in my repository. But also, it's co-located with your repository, which means Puppet is no longer responsible for some of the deployment orchestration, or you might have something in Rundeck or Ansible Tower that lives outside of Jenkins. I can now get some of this stuff into Jenkins, which is beneficial, which I think is neat. Whoop. Sometimes this doesn't render right. So we'll have to suffer through this awful rendering. Terminals, what are you going to do? So one of the nice things for the Jenkins project, we've been around for a while. We have a lot of existing freestyle jobs that are already floating around that I would like to integrate into our Jenkins file concept. I want to get those benefits of reviewing code. And with the pipeline plugin, I can still orchestrate some of those freestyle jobs from within a Jenkins file. And if you're in a transitory period, what this means is you can start invoking jobs you've already defined, get the benefits of higher level visualization, get the benefits of the Jenkins file without needing to change all your jobs. You can slowly work towards changing your jobs as time permits, or even add new steps into your pipeline with pipeline as code, but still leave the executions of your pre-existing jobs as they were. There's a couple important pipeline plugins that I strongly recommend, like pound fist on podium, strongly recommend. I don't think that any Jenkins installation is complete without at least these three. I would add Blue Ocean to this now. The Cloudbees Docker pipeline plugin allows for that Docker image inside. The pipeline stage view plugin gives you a pretty good visualization of what's going on with your pipeline. And if you do something like move from freestyle jobs to pipeline, just the pipeline stage view plugin by itself will give you much better visualization than you had previously had for your freestyle jobs that were chained together. One of the cool things, though, about implementing and teaching Jenkins about your pipeline and modeling that out in code is really neat, I would say, higher level plugins like the GitHub organization plugin can work with Jenkins files and do new things that you didn't previously have at all in freestyle plugins or with Job DSL or Jenkins Job Builder, things like that. So with the GitHub organization folder plugin, I can point Jenkins to a GitHub organization on GitHub or GitHub Enterprise, and I can say, find me all of the repositories with a Jenkins file and all of the branches in those repositories with the Jenkins file, and auto-populate the jobs as they should be inside of Jenkins. And what this means is, as a Jenkins administrator, I no longer create jobs for people. If you provide a Jenkins file, the GitHub organization folder plugin allows you to never create a job again because it auto-detects Jenkins files that have been added into your GitHub org, which to me, automating automation is like super cool. But anyways, so enough with the cool stuff, back to the hard stuff. Infrastructure is really hard, right? But there's two important ingredients to go from infrastructure is really hard to I'm surviving and I can implement continuous delivery, and even maybe I'm happy about where our infrastructure is. And these two ingredients are testability and consistency. And I want to talk about testability first. Like I mentioned earlier, there's not been a lot of tooling in the various configuration management tools or infrastructure as code tools up until very recently that allow you to test your infrastructure code. And there's a couple different layers of testing when we talk about infrastructure that we need to consider. The most basic one is unit testing. When I describe this little piece of code, does that little piece of code do what I think it should do? Acceptance testing, which is, does this meet my acceptance criteria? And the other one that I don't think a lot of people think of as testing is monitoring. Monitoring is, I would say, the closest analog in normal application development would be synthetic checks or synthetic transactions. Monitoring is how you know that the thing you said was going to do what it should do is still doing it. And so I consider that an important part of testing. And in at least our infrastructure, there's tools for other tool chains like Chef and Ansible. In our infrastructure, we're using RSpec Puppet for our unit testing, ServerSpec and Beaker for our acceptance testing, and then a little bit of ServerSpec and Datadog for our monitoring, which I consider testing, right? So if you're not familiar with how Puppet works, here's an easy high-level overview. You model a graph of stuff. So stuff being a package, a file, a service. You basically build up this big graph of stuff and then execute on that on a machine. And with RSpec Puppet, I can describe what should be in that graph in little bits of code. So this might be a very contrived Puppet class where I'm defining a Jenkins repository. And the only two things I really need to do here, I need to pull in the apt module and then define a resource apt source. And this will create a little graph that's only got two resources in it, right? But I can use RSpec Puppet to define what I expect to be in that graph. I haven't actually executed this on a machine, but I've got the Puppet that describes what should be in the graph, and RSpec Puppet gives me the ability to verify that the things are where I think they should be in that graph. So you might be looking at code like this, which is very simple and straightforward, and say, I just wrote include apt, and I just wrote apt source. Why would I need to write a test for that? I know that those are the things that are going to be in my graph, because it's so simple. But with infrastructure as code, one of the nice things that you get from tools like Chef and Puppet is branching. So I might have multiple different platforms I need to support, or different data centers, or different types of Jenkins repos I need to support. And as soon as you add branches into your code, you now have something that can break in unexpected ways unless you add your tests for it. So in this case, I'm relying on this OS family fact. So on Red Hat family systems, I want to do one thing. On Debian family systems, I want to do another thing. I have logic. Therefore, I need to write a test for this. And the RSpec Puppet's pretty straightforward for that. I can mock up my fake sort of system, my fake facts. I can say, here's the OS family. We're going to pretend that we're running with Red Hat family. What should be in the graph? Make sure that that's there. And the same for Debian. And if you're writing tools like Jenkins, or writing things like Puppet modules, this becomes incredibly important. I'm one of the co-maintainers of the Puppet Jenkins module, and there's a lot of people who use that on Red Hat. I don't use Jenkins on Red Hat. There's a lot of people that use that on other Unix variants that I don't use. And without RSpec Puppet and without some acceptance tests, there's no way that I could safely make a release without breaking some variant platform that I don't directly test on. And if you're writing anything like Puppet modules or Chef cookbooks, please, please, please write some unit tests so we can trust your releases. Cool, whatever. So refresher on how Puppet works. I know I said this already. It's a graph of stuff. And that graph of stuff is really, really nice, but it doesn't actually mean anything until you provision a machine. And this is sort of the wrinkle with just about every configuration management tool, is you can write as much infrastructure as code as you want, but until you provision a machine, there's no guarantee that what you're specifying is actually what you're going to get. And it's not a problem with Puppet or Chef. It's you might be specifying things in a way that doesn't result in the end state of a system that you actually want. So you simply haven't told the computer what you want correctly. This is where server spec comes in. Server spec allows you to define what the end state of the machine is that you want. And you can use server spec to point it at a specific machine, or you can stand up a node with Vagrant and run server spec against it. But like RSpec Puppet, it's a very simple RSpec DSL. It's fairly well documented, serverspec.org. But in this example, I'm describing what a www host should look like. And if you just imagine an Apache host sitting there, how would you describe an Apache host to someone who's not looking at the files on the machine or looking at your Puppet? You would say, well, the service that's Apache needs to be up and running. We need to be listening on these ports, and you might have other things that you need to describe. But what we're doing in server spec is describing the end state contract for what our infrastructure should look like. And the nice thing about building on top of tools like RSpec is a fairly mature unit testing and acceptance testing tool for Ruby. There's a lot of features as a test framework that you can just get for free with server spec because it's already built on top of that. And one of the features that I'm very fond of is this notion of shared examples. So shared examples are a way of describing common behaviors in RSpec that we can use here. So I have a plethora of Linux hosts running around. They should all have some fairly standard, basic setup on them. In the Jenkins project, for example, every Linux host should be listening on port 22. Password authentication should be disabled in the SSHD config. There should be the Datadog agent running on them. And there's a few other things that I had to cut off because the slide's pretty small. But this gives us something that we can then throw into every other server spec example and say, not only is this a standard Linux host, but it should also have Apache running that should be listening on this port. And as you get further and further into developing these acceptance tests for your infrastructure, you start to have a really nice model for what the infrastructure should look like in a way that makes sense to a running Linux machine. Not to Puppet necessarily, but to the end state, which is neat. And then we get into monitoring, going up that sort of testing pyramid, unit tests at the bottom, acceptance test, monitoring I put up at the top. And this is something I don't want to go too deeply into because we're using Datadog, so there's fairly specific ways that you would use Datadog versus Nagios versus Sensu or something else to do your monitoring. But defining these as part of our code means that we've got Datadog checks that act as part of our test system that go into our infrastructure code and then get deployed out to production along with the rest of our infrastructure code. So there's these multiple layers. I encourage you to implement at least something at each of these layers in order to sort of start moving down that path of continuous delivery for infrastructure. Yeah, so let's look at another Jenkins file. What's a good one? How about infra? So we spent a lot of time going down this path of like, we need RSpec Puppet, we need server spec, we need a couple other tools. And that by itself was all fine and good, but we needed to plug that into Jenkins. And so the first cut of our Jenkins file that we worked out was doing some basic stuff. I built this Docker image that's got all my system dependencies, so I can just drop this on our Jenkins cluster without having to pre-configure anything. And we've got one stage, which is just linting, making sure that our style guidelines are being adhered to. One that's just making sure our RSpec stuff. And then we've got some other weird stuff that we have to do because of how the project is set up. We make sure that our zone files are actually correct. And the reason that this exists is because they weren't correct and I screwed something up. So I had to add a check to make sure that I didn't screw that up again. But because this is code, I can start to do interesting things like refactoring and making things faster. If you've ever tried to parallelize different steps of your freestyle job-based pipeline, you'll know the pain of trying to take an existing series of jobs and make things faster. Because everything was in a Jenkins file, I could refactor it from the version on the right, which was the original. Let me switch this around, actually. So over here, I've got all of the stuff that I started with, which is a very slow, sequential, just run the tests one after another. And what I discovered as I started to run this over and over again is these different stages aren't actually interdependent. So if I run everything all at once at the beginning, then I can get feedback in 5 or 6 minutes as opposed to 20 minutes for the infrastructure code. So I started to use parallel and refactoring some common behaviors. Because this is just code, I can apply, don't repeat yourself and refactoring patterns as I might any other piece of the code in our infrastructure. So all of this is fairly straightforward. At least I think it's fairly straightforward. The new declarative pipeline stuff makes this a lot easier to get started with. But having pipeline scripts sort of behind the scenes or as a tool to go extensible gives you a lot of power and flexibility as your continuous delivery for your infrastructure continues to evolve. So I think that covers, at least for our infrastructure, the testability component. And now I want to talk about the consistency thing. There's a couple ways to get consistent infrastructure. And when I say consistency, I mean the thing that I built in Jenkins operates, behaves, and basically is the same thing when it's running out in production. VM images are a pretty common way to do that. Packer's been used for a long time to build these sort of consistent EC2 images or Azure images that you can just deploy out from there. Containers are the new hotness, and that's one way to do it. Another way is to model out what your clusters and what your infrastructure actually looks like with a tool like Terraform, which is going to assert that things are where they're supposed to be. In our case, we're all about Docker, for better or worse. And the pros of Docker is that in our infrastructure, it's actually very easy to use Docker on physical infrastructure. If you've got physical hosts running around, by adding Docker into the equation, I can reuse those physical hosts for multiple different services and get some isolation between the two in terms of lifecycle management, to some extent security, if you structure your Docker files correctly. It also gives you a consistent application environment. So whatever container was built in Jenkins, it's going to behave the exact same way on one host versus another. And it's rapidly evolving, so it's getting a lot better as time goes on. We jumped on the Docker train 2 years ago, and Docker today is vastly better than Docker 2 years ago was. But there's still some drawbacks, of course. Nothing ever comes without a cons slide. So one of the challenges with Docker for your infrastructure is deciding what goes into your Docker file versus what goes into Puppet or Chef. Things like that. A lot of people, and I see this in probably 90% of the Docker files that I've ever seen, the first couple steps are like apt-get update and apt-get install some stuff. Basically some basic configuration management handling, copy some config files into the container, stuff like that. And it can be difficult as your organization grows to know where do we draw the line. We have Puppet or we have Ansible and we have Docker. What goes where? This is something that is, I think, a case-by-case sort of decision to make. We decided, and I'll show you in a bit, on drawing the line at configuration, but not necessarily packages. But that might be a different line for you. Docker networking relies on IP tables, which is black magic upon black magic. And sometimes it doesn't work the way you might expect it. And if you're using things like linked containers or some of the more advanced Docker networking features, depending on your kernel version, depending on your Docker version, you might run into a scenario where traffic just starts getting black-holed because of some issue or some misconfiguration. And the process is running, you think it's supposed to be running, it's listening on the port, but deep in the NAT table, in IP tables, something's getting routed to a black hole IP. That kind of sucks. The image also becomes another thing. And what I mean by that is if you've got an application, you've got one life cycle you've got to think about. If you've got your Puppet code, you've got another life cycle to think about. As soon as you throw Docker in there, you've got a third thing that you need to start thinking about. How do we manage the application life cycle of the Docker container? And it's rapidly evolving, so you might fall into API breakages every now and again. This has gotten dramatically better in the past 12 months. But I recommend sticking with the Docker upstream packages and updating at least once or twice a year so you don't have to make big API version jumps that might break some of your automation around Docker. So in the Jenkins project, we use it in a couple different places. And I mean, there's no nice way to put this. There's some ugly things that are difficult to manage, and we put those in Docker containers because that makes them less ugly and less difficult to manage. If we had some really great Debian packages for things like Jira and Confluence, we probably wouldn't be using Docker for them. But because we can't get really good Debian packages for Jira and Confluence, we decided to Dockerize them. And then there's a couple other things like bind, where we want to run the same exact version of the bind application with the same exact configuration and properties on multiple different hosts. Putting that inside of a container means that I've got consistency if I've got 3 nodes out there in different regions that have the same application running on them. I can rev the Docker container and then push that out, and everybody's up to the exact version of what I expect them to be. So let's look at some simple Docker files. Do I have a basic? Let's look at bind. Bind's pretty basic. Like I mentioned, 90% of Docker files, they start by installing some stuff. But this is where our line gets drawn between Docker and Puppet, for example. We will mount in, we'll use a volume for where we're going to provide the zone files and the bind configuration. We'll do some of the other basics inside of the Docker file, but the actual configuration that might be environment specific, we'll drop that in Puppet, and we just mount that into the Docker container. So that's fairly basic and not all that impressive. Where things get really impressive is with our Jira container. And this is all open source. This is all on the Jenkins infra repository or organization in GitHub. But before this Docker file, and I'll just slowly scroll through it. Before this Docker file, if we wanted to upgrade Jira, we had a wiki page that had a list of all of these stupid steps that you had to do to install Jira on a local Vagrant instance, verify that it works, and then good luck getting that out into production. And as a result, we didn't upgrade Jira very often, which is not a good thing to do. Point of order, don't do that. But by defining that set of steps inside of the Docker file, not only do I have a documented way that we construct the image for Jira, but when I build and test that Jira image locally, I know that it's going to behave the exact same way once I deploy it out to production. And for no other reason, this is immensely valuable because I'm no longer tinkering with Jira in production and trying to match it up with what I've got locally, or trying to make sure I'm downloading the right tarballs in production to unpack and start Jira up. I do that once in my CI tool, and then I send it along to production. And I've got a very consistent Jira deployment as a result of that. So the Jenkins files for those are also fairly simple. Like I mentioned, you should use the Cloudbees Docker pipeline plugin. This is how we build and deploy our bind container. We just call build, and then we push it. And then we've got something in Docker Hub that's ready to use. And so if you're building Docker containers, there's a lot of great tooling in Jenkins to make the continuous delivery of those containers a lot easier than you might be expecting. So we've got some Docker stuff running around. That's another thing that we've got to manage. We've got to bring our Puppet code, which we're writing and we're writing tests for, and our Docker code together. And this is where the Docker Puppet module that we're using comes into play. We actually use Puppet to orchestrate our Docker deployments. And there's a couple benefits to this. One is we can use variables that we have available in Puppet to determine how to configure or where to deploy different kinds of containers. But also, we've already built a Puppet deployment pipeline. So now our Docker deployment pipeline is just our Puppet deployment pipeline. We don't have to build a separate delivery process just for our Docker containers because we're bringing that into the Puppet ecosystem. So to get to that continuous delivery of our infrastructure, we've got these two ingredients now. We've got our tests and we've got our consistent containers that are floating around. And if you've been closely paying attention, you might have noticed that I actually didn't deploy anything to production, which is kind of cheating, right? And this is where R10K comes in, at least for Puppet. There's different tools for Ansible and Chef to do some of this production deployment. In our case, we're using R10K to manage production versus staging environments from the same Puppet master. So when we're going to production, we're really just merging stuff from one branch in Git, that's the staging branch, into our production branch. And what R10K allows us to do is roughly think of a Git branch as an environment and then provision nodes with those different environments. And in our case, because we're using GitHub, we actually heavily rely on GitHub webhooks to sort of complete the entire picture. Stuff will go into GitHub as a pull request. We'll start to run our tests on that. We'll make sure that everything is hunky-dory. That will get merged into a particular branch that gets deployed out via R10K, and that's all sort of orchestrated either through Jenkins or through some webhooks when certain events happen in our source tree. Kind of roughly speaking, it looks like this. We've got our pull requests where we do our automated tests and our manual code review. I strongly believe in code review, especially around infrastructure code. And we can make sure that we're merging code in that's good, and then the actual deploy to production is just merging to the production branch. And then webhooks fire, and then the Puppet master updates, and all the Puppet agents come in and get their new Puppet manifest, which might include new Docker containers which get deployed out. But there's some stuff missing. This is still a work in progress. We don't actually get results back into Jenkins. And this is something that I've wanted to do for months and months and months. I want to know when stuff hits a production host. And there's tools like the Puppet plugin. There's a Chef deployment plugin as well. There might be support for this in the Ansible plugin. There's tools that will tie production deployment feedback back into Jenkins that would give you a nice complete picture on where things are and when they were deployed there. We currently don't have that. We also haven't fully switched over to Beaker, which is a Puppet acceptance testing tool, which is a much better improvement over what we had been sort of hacking together before. And we also have to migrate to Azure, which you may have heard about. The nice thing about migrating to Azure for us, and really if you're not running on a platform as a service already, the nice thing about them, whether it's OpenStack or AWS or Azure, or Google Compute, can't leave them out, you can start describing all of your infrastructure down to those resources, your load balancers, your virtual machines, things like that, in code, whether it's through Terraform, whether it's through CloudFormation or Azure Resource Manager. There's tools to where you can approach the entirety of your stack as if it's code and treat it just like any other piece of code you would deliver. Like I said, though, open source infrastructure is difficult, so there's a lot of stuff that we have to do. But our continuous delivery pipeline makes things easier. Like our pipeline, our Jenkins file is our documentation for how things get delivered, which is very useful if you've got people distributed around the world that contribute to a project. We can't always jump on Google Hangouts to explain how things work. So having that documented and implemented in code is extremely beneficial. It also makes our fire drills a lot less prevalent. We very rarely screw up production anymore. When I first started working on this, I was getting paged at least a couple times a week. I got paged once this week, and that's just because some disks weren't being cleaned up like they were supposed to. But that's pretty much the most I get paged for. We've not had a production deployment cause an outage since I screwed up that zone file that I mentioned. I added a check for that in our Jenkins file for. And that was 8 months ago. So 8 months of deploying production, maybe 3 or 4 times a week, and we haven't had a production outage because we're pushing all of this work closer up to the development as opposed to letting our users beta test this stuff for us. And that makes it easier to work with. I didn't say this originally. I don't know who said this, or I don't know who I can attribute this quote to, but you should only automate the things that you care about. And there's a double-edged sword to this. If something's really important, automate it. But if you're in like super MVP mode and you don't really care about this application, maybe don't do a full top-to-bottom continuous delivery stack. Just play around with like Heroku or Code Deploy on AWS and just get it out there and learn stuff about it if you don't care about it. But if it's important, you've got to automate it if you want to be successful or want to keep growing. So there's a ticket, and since you're in this talk, I assume you might be interested, about some system configuration stuff that we've been talking about in the Jenkins project on how we can automate Jenkins itself. I think Stache talked a little bit about what Cloudbees is talking about doing around this. I would love to see this happen in the open source project. There's this ticket where there's some discussion from the Puppet Jenkins co-maintainer, my co-maintainer, and a few other people that are automating Jenkins itself. It's a hard problem to solve with stock Jenkins, so we need to improve Jenkins to make it easier to automate. Because you should only automate what you care about, and I care about Jenkins quite a bit. The other thing I should mention before I get booed off stage is the Jenkins Project's infrastructure is entirely open source. So if you want to know how we're building containers, if you want to know how we're using Puppet, or what our monitoring looks like, all of that is on GitHub under the Jenkins infrastructure repository. All of our organization, all of our Docker files, Jenkins files, everything is there except for our certificates and keys and things like that. So if you see an application that we've deployed that's interesting to you, please go find it and look at how we're building our containers and start from there. That's my time. Oh, no. What else do we got? That's it. I don't have any time for questions, but I will be at the open source hub pretty much the rest of the day, and then tomorrow. I love talking about infrastructure, and I love talking about testing it and automating it with Jenkins. So please come ask me questions there. Thank you.